everybody, and oops, sorry about that. Welcome to episode 8 of my how to build an advanced 8-bit computer inside Minecraft. It's been a while since I've done one of these videos. I've been doing other stuff like the 1.5 update, and then I really got into Feed the Beast recently, and I might be doing some gameplay of that because the amount of stuff you can create in Feed the Beast and Direwolves mod pack and all that kind of stuff, simply amazing. Oh yeah, and I've also been playing on the Voxel box, doing a load of building on there, just standard like architectural work. And what else have I been doing? Oh yeah, I have organising some stuff with Benny. I don't know if you know about him. He's a fairly well-known YouTuber. We've got about 2k subs, I believe, and he does similar videos to me. So we decided we'll do a video together, and I chose the topic. So I've decided that we will do a video on the changes and all the new awesome stuff in 1.5, and I hope that'll be interesting as well as factual, and be a good laugh to do something with it. Anyway, back to the computer. So we finished the ALU, got the shifter and all that jazz. I'm still playing in 1.4.7 because I don't know if single player commands and world edit has been ported to 1.5 yet. It probably has, but I haven't been bothered to check. I'll check after this episode. So what to do now? Okay, so we've got all of our commands, but they're all a bit all over the place. I need to bust them into one place, and then I need to add a decoder so we can do opcodes, and I'll explain the opcodes at the end. So I'm not going to take you through busing. You can pretty much do busing, just taking it from one place, but I like to start in the middle and then take that up to about halfway. So if we build something like this, where shall we take it to? Take it up there, and just keep on going. That's not halfway, is it? No, it'll do. Okay, so I'll have all of my stuff running all the way up to about this level, I think. So now what you need to do is, now I've built one as just an example, you need to make sure all of these commands are bust so they're one apart from each other, and then I'll just tell you the order which I want them to be. So we'll have invert A first, then followed by invert B. After that we'll follow by bypass the adders. After that we'll have set carry 1. After that we'll have cut carry. After that we'll have the scene on, which we already have, and then finally we'll have the right shift, which is already nice and lined up there. So I will be right back after I bust these in line. Okay, so here we are then. Oh, I should really take that off. It knows the hell am I. Anyway, so here we are then. All of our 7 commands have been bust into one line, and now I'll just label them to remind you of the order which they should be in. So first of all we have invert A, followed by, let's have that up there, invert, wow, I can't type today, invert B, followed by what looks to be bypass the adders. So we'll do that, called bypassing adders. Adders, okay, no, adders, okay. After that we will have, let's have a look, set carry 1. Why is that there? That should be there, shouldn't it? Let's have a look. That should really be there, shouldn't it? Wow. Did I miss out that before? I think I might have done. I apologise if I did. That should be off. Yeah, they're all off there. So sorry about that. If previous video I hadn't placed that piece of redstone. I fixed it now. So now we've got bypass adders. After that we have set carry 1. Followed by cut carry. So set carry 0. Set carry 0. So I'll just explain that. I think I've always referred to it as cut carry before, which hence the name. It cuts the carry, doesn't allow if a carry is generated. I hope you know what a carry is by now. I've done it for like 5 freaking episodes. Yeah, so if a carry is generated between 2 adders, it stops the carry from being through. But you can also say that's setting the carry to 0, because if nothing's through, they all must be 0. So yeah, that's why I've called it that. That can only be on 1. That needs to be on 1. So now I've got those, followed by scene on. So this turns the initial carry in on, necessary for subtraction. And finally we have right shift. Right shift. There we go. That means you don't need these signs now. Keep that there, that's the underflow. That's actually like a flag, or a condition. It's not a function. Any more? Nope, I think that's it. So we have got all that, and now we can just test that they all reach. And we'll get some arbitrary output, but well. Yay, all of the things. Okay, let's check that they all get to their corresponding places. So that one does. This will just show you how I've bussed it. It's like, it doesn't really matter as long as it reaches. That reaches. That one reaches. This one is the longest one, I think. Yep, that reaches nicely. When we're up to just in that one. That one's got 3 blocks to go. That reaches scene on. Bit of a wiggly bus. That reaches, and finally, right shift has only got to go to there, so that reaches as well. So I have everything set up now. I might have caused some block drops by doing that. If I have, I'll fix them just by placing them again. So now we've got that, I need to go and change my Minecraft jar version because I realised I don't have single player commands. I've got the voxel box one, so I'll be right back. Okay, I'm back, and as you can see, I was greeted with a nice message telling me that the new single player command is out, so I will go and check that out. It says it's for 1.4.7, but I think it might be for 1.5 as well, because I'm using 1.4.7 at the moment, so. Ooh, pardon me, you know. Anyway, so we have that, like that, and you're thinking, what's the point of this? But I'll tell you. Now we will build the decoder, because at the moment we have like the hardware commands. We have invert A, invert B, bypass adders, set1, blah 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 blah, and we need to turn that into actual commands like add, subtract, or, and all of those. So to do that, we do a standard torch decoder. So let's just come out there and stack this a couple of times. Well, all the way down. So stack 7. Oh yeah, I oops. Undo. Expand 1. Stack 7. Yeah, that's okay. Stack 6. So anyway, so what was I gonna say? Oh yeah, I realised I was being stupid the other day. In one of my previous episodes, I said that my wooden axe wasn't working, and that's because I don't know why it wasn't working, but to fix it, you can just do //wand, and that fills your inventory. If you didn't realise that, with a just fills one slot of your inventory with a wand. So that is, yeah, me being a bit derpy, to be honest. And now let's do this. Build like a row all the way across with that on it. So as you can see on each of this, you might recognise this from like my program memory. That was like this decoder. We can place a line like that, and at the moment, what's this doing? That's doing invert B, set carry 1, and scene on. I have no idea what that would do if we input any data, but yeah, we can each line of this will have a different torches placed on it, and those torches will then like equate to a function. So we've got this, and I just need to have how many functions do we need? I'll stack it 9 times, so I think we'll have at least 10. So let's go through and stack 10, 9. Alright, so now we have 9. It's a rather large decoder jutting out the edge, but you know. Ah well. Okay, so let's start with OR, the very most basic of commands, and OR is bypass adders and set carry to 0. While we're at it, let's no, I'll do it at the end so don't catch flickers of the torch, so don't cause torch flickers. So that's OR. I'll label these. Where's the middle? OCD alert. The middle is there. Okay. So that's OR. And now we want to do NOR, which is the opposite of OR. So we will have the same kind of setup again. We'll have that. And that. And we also need to invert the output. So we need to what do we need to do? Set carry to 1. And so cut the carry and then set the rest of the carry to 1. So where's that? Yeah. You might think that's a bit counterintuitive, setting carry to 1 and setting carry to 0, but believe me, it's not. It actually works like that. So we have this. Now for what should we do? And I know I think in a previous video I said that AND required you to use this bypass adders operator, but it doesn't. You actually do AND by the following. You invert A and invert B, and then you also invert the output, which is setting carry to 1. So at the moment, that's what we've got for that. So that's AND. And now for NAND, which, like if you're building a normal gate, is just an AND gate without the final torch in it. If you remember building that from back when I did all my logic gates tutorials, which I'm remaking at the moment, actually. So yeah, for NAND, you just place those two on. Now, what should we do now? XOR, I think. Yeah, let's do XOR. So we have XOR. XOR is simply setting the carry to 0. Oop, sorry. So it's this one. Come all the way back here and place touch in there. Opposite of XNOR. XOR is XNOR. Well, a bit of a mouthful. XNOR. And that is the same, but with the set carry to 1 as well. So that's just those two. Now what? So we've got OR, NOR, and NAND, XOR, XNOR. They're the 6 main logic gates. So now we'll just have addition as one, and by default, so for addition we'll say A plus B. So addition doesn't need anything. And now we'll have A minus B, which is the like the symbol for subtraction. So we have A minus A plus B, which requires nothing, and A minus B. And so if you want A minus B, you need to add, so nothing. Then you need to invert the B input, which is the minus. So that is, let's have a look. That's this one here. So invert the B input, add, and then you also need to turn the carry in on, which is this one over here. So you need to turn the carry in on. And then I believe you also need to set the. Do you need to invert output? 1 second, I'll be right back. Okay, so I'm back. Quite a lot longer than I expected, but you won't know that because it'll be seamless. I hope. No, not really. But yeah, I've had a look and I've realised that you only need these two. You only need the carry in and A minus B, I think. That's why I had on my other computer, but I'll need to double check that again. I still could be making a mistake. My 2's complement knowledge is failing me so bad right now. And now, so we've got A plus B and A minus B. If we want to do, let's have a look. Minus B plus A, no. That's the same, isn't it? No, B minus A, that's what I meant to say. B minus A. We simply invert the other one and do xenon, and I think that's it. Oh yeah, and finally multiply by 2. No, right shift, left shift, divide by 2, sorry. So that's that one. Let's just go like that. Okay. So in my other computer, not in the one that I built on, while recording, I mean another computer built solo, I had also had one to like just flood 1 and flood 0, which is like just send a load of zeros through and a load of 1 through, and that's good for when you want to zero out registers. But I haven't included that because that means I need to have an inhibit function, and I haven't added that on for just to keep it nice and compact, really, I guess. So now we have that, we need to disable them all by default and build one more decoder, which will provide the opcodes. So we have that and that, and place that there. Stack that 8 times, I believe. Oops, I forgot to add the touches. Yeah, 9 times, sorry. Not 8, because there are 10 functions. Okay, so now we have that, they're all off by default, nothing comes through. And we need to build decoder, so since we have 10 here, what bit decoder do we need? We need a 4-bit decoder. So I'm pretty sure you can build a decoder by now, and I really don't want to do this on camera. So I'll show you how to build the first 2 bits, and then I'll do it the rest off camera, because it doesn't head in built-in stuff like that on camera, because there's nothing to speak about. Like, you've got to actually pay attention to what you're doing, otherwise you get lost, and that then means, well, if you're like me, it's kind of hard to do something complex and commentate on something reasonable at the same time. So yeah, that's why I don't like doing them. So we have that as 1, and all these down as zeros, pistons above them all. Nope, destroying the wrong blocks here, like you do. Pistons and piston there. So as you can see at the moment, this is 1 in binary, 0, 0, 0, 1. And now for the next one, we do a 2. I hope that you've all built this decoder before. If you haven't, this is kind of a crash course in it, I guess. But go and watch another one of my videos. I can't actually remember which one it's in. I should do a dedicated video to this decoder, shouldn't I? Well, it's so many times, and I can just say, go watch it, and oops, and be done with all of this nonsense. Anywho, so that goes like that, and that goes like that. So now, as you can see, this is the what the heck? Yeah, place it. Okay. Whew, there we go. So this is the number 2 in binary. The second one along. We have 0, 0, 1, 0. That's number 2. And then you just got to carry that on for the other 6, which is a bit boring, but you know it's got to be done. So I will cut the video here and restart again when it's finished. Okay then, so here we are. We have I've finished the decoder. As you can see, this is in all of its glory. Hopefully you built something like this, like the lines on top might be a little different, but should look the same. So it goes like this one up, and then the second one up, the first 2 up, the third one up, the third and the first one up, the third and the second one up, the first 3 up, the last one up, the last one and the first one up, and the last one and the second one up, and all the rest down. So that's how that decoder looks, and now we have a fully opcoded ALU. So let's say we wanted to do a standard addition, A plus B. We look over here and we see that this is the 7th one. So now we opcode it in 7, which in binary is 4 plus 2 plus 1. So we have 4 plus 2 plus 1 coming through. That is then decoded in the opcode decoder. Goes through to here, and as it's addition, doesn't require any torches, so this decoder isn't really needed for that. Nothing is turned on, and if we add 1, I've got dropped pistons everywhere, look, from various things, so I need to I just need to quickly go through and have a look to see where I've dropped all my pistons. Basically, I just need to activate all of these one by one. Okay, so oh, why isn't that fit? Oh, these have all been dropped as well. So that means I need to set the bypass adder to that's the pain about building decoders. You get like flashes coming through there, and that's decoded here accidentally. And oh no, I can do this a better way. I can do that, and then I can invert A and invert B. So hopefully that's picked up all of these. That's picked up all of those. Yep. And that should be that. Right then, I should set it to day, and I'll do my demonstration once again. Why is that being decoded? What's that coming through from? Oh, there it is. Silly me. So now nothing is coming through this decoder because we're adding. Put a 1 through, another 1 through, and yay, a 2 comes through. So 1 plus 1 is 2, and we're using the 7th opcode, which means we're adding. Now let's do subtraction, and then I can test whether I've built it right. So what's subtraction? Subtraction is A minus B, which is the 8th opcode. So we put 8 through on the opcode here. 8 is 1000 in binary, so that's going through here, been decoded. Now it says A minus B, so these two are going through into the ALU, and it says invert B and carrying on. Nothing should be going through, and since it's A minus B, the A input, which is the bottom input I believe, yep, the A input needs to be higher. So let's do 10 minus 5, so 1, 2, 4, 8, 8, and 2. So that's 10, so hopefully 10's coming through right now. That'd be nice. 10 is coming through, and if we subtract 5, subtract 1 and 4, I'm hoping that 5 comes through. And look, 1, 2, and 4. 1 and 4 are coming on. 5, so 10 minus 5 is working perfectly. As well as this might be on. I wonder if that has anything to do with... You know, let's just leave that. I don't think that matters at the moment. If it does, we'll come to it later. So yeah, so that's subtraction. And let's do one more demonstration, because doing 3 is always a good idea. To prove it's not a fluke. So an addition and subtraction using our opcode. So as you can see, this is so easy. You do all of these functions in just four of these. And when we finished it, I'll do a little documentation so we know which opcode goes to which actual function. So what do we want to do now? We'll do anding, which is the 3rd. So we'll have 3 on the opcode. That might cause block drops. Doing it so quickly is not a good idea. It has done as well. That's just superb. What's being dropped? What's being dropped? It's just this that's not coming through, isn't it? You know what? Let's just leave that one. I can't bother going to figure out the drop box. Alright. Looks like they've all been dropped somewhere or another. Because everything's been output. Yay! I just love block drops. I wish one tick pulses didn't exist at times. It's infuriating me. So they're all off, which means... What the heck? Oh no, that's right. I'm stupid. I'm so derpy. Why is this doing this? I really have no idea. what is going on. These shouldn't be letting. Oh right, it's these pistons again. These pistons here are doing my head in. You know, I'll since we know that these are the problem here, I'm going to I'll probably do like a reliable fix in the next video. But for now, that's just going to be a temp fix. And as you can see, nothing's coming through. So I'm sorry about that little error at the end, but as you can see, we have a very nice looking ALU. Now we just need to add some memory. Woo. So yeah, I hope you enjoyed this video. So it's a bit long. Please stick around for more. Thanks.